Well, hello again, everybody. Tomorrow is a test in Chapter 2 Graphing, and I know we already went over this one graphing practice sheet in class, but I figured it couldn't hurt to have a copy of it on the website as well. So we're going to be going over the ball rolling down the ramp problems together here, and remember that number 4 and 5 we're not going to do, so it's just 1, 2, and 3. So here we have number 1, and again, I believe we went over this one actually together in class, but I took the liberty already of writing down the 3 equations for our position as a function of time, velocity as a function of time, and acceleration as a function of time. All right here. Now, of course, our acceleration is going to be constant, so whatever our acceleration starts at, it will end with, but our velocity and our position will certainly be changing with time. So let's look at this. This is number 1. Consider ball rolling down a ramp. Well, we have an initial velocity of 0 right here, and our initial displacement is 0. And we can tell from the way the ramp is oriented that we're going to have some sort of acceleration in this direction. Well, it's accelerating from 0 to 25 and then 50, and it's moving from point 0 to 25 on to 50. So the acceleration is going to be a positive acceleration. It's going forward. The object is gaining distance. So let's write this right down here. There we go. Our acceleration is positive. Do we know exactly what value? No, but it's simply going to be a constant positive acceleration, which means we pick a positive value on our acceleration graph and we simply make that constant right there. So it's constant, 1 meter per second or 2 meters per second or whatever. Okay, let's go on now to our velocity as a function of time. Well, let's write our equation first. You recall that this is our equation right here for velocity as a function of time, VI plus AT. But if we look at our free body diagram, what's our VI, or in this case, it's called VO. Again, this notation changes from time to time. That's actually VI, and this is XI right there. Well, that equals 0. So that goes away, but we do have an acceleration. We have a positive acceleration. So that will be simply acceleration times time. That means over time, whatever value, whatever value acceleration is over time, as time ticks off, that will increase the velocity because there is an acceleration over time. So if our velocity starts at 0, like we have above right here, but that tells us on our graph we start at the origin, or starts at 0. And now whatever value the acceleration is, that is whatever value that is right there, that's going to be our slope of our velocity versus time. So if that's 1, then we're going to have a slope of 1. If it's 2, then here we're going to have a slope of 2, and so forth. So our velocity is increasing with time because there's an acceleration. There's a positive acceleration. All right, now our position versus time. Position versus time we have is our initial position plus initial velocity times time plus 1/2 times acceleration times time squared. Well, we will look at our initial position first, and that's 0. So this goes away. And our initial velocity is also 0. So that goes away as well. So all we're going to be left with is 1/2 AT squared. 1/2 acceleration times time squared. Now, if we look at this, and actually if we compare it to our velocity versus time, look at our velocity versus time. What's the relationship between velocity and time right here? Well, it's a linear relationship. They're not increasing or decreasing by any powers or inverses. It's simply as time increases, velocity increases, and so we have a straight line. But if we compare our position versus time here, we've got a squared relationship. So we can conclude that it's going to be a curve. And since the acceleration is positive, it's going to be a positive curve. All right, so where do we start this position versus time graph? Well, we're told that our initial position is 0. Okay, so we're going to start it here. Our initial velocity is 0, which means that the slope of position versus time is going to be 0. But since the acceleration is positive, it's going to become more and more positive over time. So we'll have a graph kind of like that. So acceleration versus time is constant. Velocity as a function of time is linear. And our location, or that is position as a function of time, is going to be a curve because we've got a squared relationship between our position and our time right here. Let's go on to number 2.